Hello everyone, this is the first lesson recording for IM1 September 30th, 2020. We started off with a quiz on exponent simplification. So if you're watching this video because you were absent, then you need to contact me, Mrs. Van Horn, as soon as possible. What are we doing today? We are going to continue study on linear functions using tile pattern. So we are going to be considering what information can I get from a table and what information can I get from a graph. So to begin, let's just review what we did 2 lessons ago. So we started off with this figure, and then we tried to figure out figure 0 and figure 4. So to do that, the easiest way is to color the previous shape. Okay, so if I was to color the previous shape, figure 1 in figure 2, let's just shade in the previous shape. Then this is the previous shape. Okay, then very easily you can figure out what the new ones were added. Okay, so from figure 1 to figure 2, the new tiles that were added was this and this. Okay, let's do the same thing with this. Okay, so then we know that we had 2 at the 2 on the left arm, and we had 1 2 3 4 on the right arm, and then you had the center 4. So we can color this in really quickly, shade this in, and then we can really easily figure out that this one was added and this one was added. Okay, so the blue indicate the new tiles that were added, and then the red indicate the previous figure. Okay, if that is the case, then we can very easily say that, oh, I bet 2 were added on the right arm here and 1 were added on the left arm here. Okay, then I can figure out what figure 0 was very easily, because it looks like there was 1 2 3 4 that looks like this. So I know that figure 0 would have looked like 1 2 3 4 just by doing what I did. And likewise for figure 4, I can just start by drawing the previous figure 3. So that there was figure 3 had 1 2 3, and then figure 4, and then 4 in the middle, and then 1 2 3 4 5 1 2 3 4 5 6 1 2 3 2 3 4 5 6. That was figure 3. This is just figure 3. Now to that I want to draw figure what was added. 1 on the left arm and 2 on the right arm. So I know figure 4 looked like this. So if you use the colors, it makes it so much easier. Okay, so that's what figure 0 looked like. This is what figure 4 looked like. Then let's move on. Okay, and from the notes, we said the starting value is always the number of tiles in figure 0. And figure 0 had 4 tiles. So that's why I have the 4 here. And the growth is how many tiles were added, and how many tiles were added in each figure? Always 3. That's how you get the 3. And then from here, you could create a table. When we had 0 figure, we had 4 tiles. When you had figure 1, we had 7 tiles. When we had figure 2, 10 tiles, and so on. That's what the table shows. And then when we graphed it, it looked like this. The x-axis was the horizontal, that's the input, that's the figure number in this case, and the y-axis is the number of tiles, that's the output. And the graph formed a line. Okay, now we try to figure out, okay, how many figures from 0 to figure 100? So if we were to ask the question, how many tiles in figure 100? Well, we don't want to draw 100 different figures, okay? But we want to look for a pattern. What happened here? So if I recall, I had 4 tiles here, and then 7 tiles here, and then 10 and 13, and then finally 16 tiles in this figure. Okay, and I know that for each one of them the growth factor was +3, +3, +3, and then +3. Okay, all right, then let's think about it this way. Okay, from each step we added 3. Okay, then from here, from figure 0 to figure 2, how many did we add? We actually added 3 times 2. We added 3 times 2 because we added 3 2 times. What about from figure 0 to figure 3? We added 3 times. So we actually added 3 times. So 3 times 3. Okay, maybe I should not be using this sign, but I should be using the dot to say that it's multiplication. Okay, and likewise, if I went from figure 0 to figure 4, we actually added 3 1 2 3 4 times. So it's 3 times 4. We added 3 4 times. Okay, so that's 12. So we actually added 12 to the 4 to get 16. Okay, so if we use this pattern, can you figure out how many times the 3 would have been added for 100th tile or 100th figure? We would have added 3 100th times, right? So for 100th figure, we added the tile grow 3 tiles 100 times, which is 3 times 100. Okay, but to that we also added what we started off with, figure 0, which is 4. So to this we got 304. So 3 times 100 is 300, plus 4 is 304 tiles. So we know that figure 100 had 304 tiles. Now we extend it to, what about figure 0? Well, if we grow 3 tiles, well, this x replaces that at 100, right? So instead of, knowing how many times, we can sort of replace it with x, and 3 tiles are growing x times in this case. So therefore, the expression is going to be 3 times x, plus we still need to add the figure 0 number. So the expression becomes, the output y is equal to 3x plus 4 becomes the equation. Okay, so we're going to move on to that. Now we're going to try to do a different tile pattern. Okay, we're going to use the same process. I want you to pause the video and see if you can figure out the figure 0 and figure 4 quickly, please. Okay, so I'm going to assume that you did this. So how would I do this? Again, I would color in the previous figure in this. Okay, so hopefully you got shapes like mine. Again, I went through the same process, colored in the previous shape. Okay, and then very easily I can figure out what was added. I could tell that 4 different corners were added each figure. That means I know the 4 corners were added here, so the figure 0 had to be the original, which is the one in the red. So figure 0 had 1, and the figure 4 would have had looked like this, and if I count this, I got 17 tiles. So I just wrote down how many tiles there were. There were 1 tile here, 5 tile here, 9, 13, and 17 tiles for each different figures. And I figured out that 4 was added each time, plus 4, plus 4, plus 4, and plus 4. Okay. All right, then what we are asked to do now is, what is the starting value of the tile pattern is the number of tiles in figure 0, and the growth is the number of tiles that are added from figure to the next. So if that is the case, what is the starting value? What is the growth? We said that there were one tile, 4, 7, 11 and 15. Is my math right? 5. Okay, so see, I make plenty of mistakes too, and you're going to make plenty of mistakes in math. 1 plus 4 is 5, plus 4 is 9, plus 4 is 13, plus 4 is 17. Good, okay? And I know that the growth, each tile grew by 4. So I know that the starting value was 1, because how many tiles did I have in figure 0? 1. How much grew? How many tiles were added? We added 4. Okay, growth factor was positive 4. Okay? Okay, now let's try to create a table with this information. We know that for figure 0 we had 1 tile. So we had 1 tile here. We had, for figure 1, we had 5 tiles. For figure 2, we had 9 tiles, 13 and 17. And now we come to the question, what if it was 100th tile? Okay, how did we figure that out before? We figured out what was added. So from going from figure 0 to figure 2, what was added to figure 0? Well, 4 was added twice, so we added 4 times 2. We added 4 times 2. From figure 0 to figure 3, we added 4 3 times. 1, 2, 3. Okay? What about here? We added 4, this time 4 times. Do you see the trend? So figure 1, we added 4 once. Figure 2, we added 4 twice. Figure 3, we added 4 3 times. And figure 4, we added 4 4 times. Okay? That means that for 105th tiles, we are going to have to add to figure 0, however many we had in figure 0, 150th times. So this is going to be 150, 4 times 150, 4 times 150, plus we have to add to, what are we adding to? However many there were in figure 1, which is plus 1, because that's how many figure we started off with. That's the starting value. That was why we found that. So which becomes 4 times 150 is 600, plus 1 is 601. We can easily figure out what 150th tile is. If that is the case, what would be the expression if we're talking about x figure? Okay, the figure number x. Then instead of using 100 here, we would use 4 times x. So that's going to be 4x. Plus 1 will be the expression for it, because we still need to add the starting figure or starting value. So the equation now becomes here y is equal to 4x plus 1, where y is the number of tiles and the figure number is x, and to that we are adding 1 to it. Okay? Good. So now we are going into some Desmos exercise where you're actually doing the work, and you're doing, please join the Desmos login, and you're doing card number 1, 2, 3, and which would look like this. Oops, no, not this. So please pause the video and do this yourself. I'm going to go over the answers. Okay, here we go. Alright, so Ben has designed the pattern, and the table below records a pattern data. Okay, so figure number 2 had number of tiles 15. Figure number 3 had 18, figure 4 had 21, and figure 5 had 24. How many tiles were added each time to figure number increased by 1? So if we can tell number of tiles went from 15 to 18 here, so we added 3, and then we added another 3, and then added another 3 here. So we know that how many tiles were added each time was 3. Okay, I am going to continue with the next video recording, so please tune in for that.